Okay, we're talking to you about orbital notation, and up to the assignment that you were given in class, everybody got through some of orbital notations for elements in the third period. Now, on the periodic table, each row is called a period. It's from that we get this name, periodic table. And it's called the periodic table because elements, the chemical properties of elements periodically repeat. So all the elements in the same column have similar chemical properties. They come around periodically. And so the periods are the rows, and the groups or families are the columns. We learned about orbital notation in previous lessons through the first two elements here in period 4. So if you need to go back and review those, you'll need to know that information to understand how to write orbital notation, and as was instructed in previous lessons. And so 2 lessons ago we went through about, I think it was boron, and then the last lesson we went from carbon down to period 3 here, but then I gave homework for you to do down through calcium. Orbital notation is a kind of inventory. An inventory is where you count things like in a store or something. You can ask your parents about inventories if you don't know. They might have done an inventory before. But you count everything in a store and you know its location. Well, with orbital notation, we're finding the location of electrons in atoms, and it's a kind of inventory system to do that. It's not the actual shape of the orbitals. It doesn't tell you exactly what that location is, but it shows you in a graphic sort of form and in letters and numbers where you would find those electrons. And so let's see. Let's start with, just for this lesson, we'll pick it up from phosphorus here, okay? So here's phosphorus. And phosphorus is in period number 3. Let me pull it down like this. Phosphorus is in period 3, and so we're going to have all of the first 2 periods full and the third period full up to phosphorus. Okay, so the first period only has an s orbital. An s orbital can only have 2 electrons. Okay, so the first primary level only has an s orbital, and that's what this number is. This number 1 tells you the primary energy level. That corresponds to the first period on the periodic table. Then when you get to the second row on the periodic table, that corresponds to putting electrons in the second primary level. So you remember the illustration where we had electrons in concentric spheres? Okay. So in the first level here, you can only have 2 electrons. That's those 2 electrons. In the second primary energy level, that's the shell or concentric sphere second out from the nucleus, this being the nucleus here, you can have up to 8 electrons. Well, we're starting with the s sublevel though. So all the elements in the first 2 columns of the periodic table are in an s sublevel region. It helps you figure out where the s orbitals are located. And helium really belongs here when we're talking about S and P and D sublevel regions, okay? So we're in the second period of the periodic table then. We're starting in the S sublevel. And you can only have 2 electrons in the S sublevel. That's because, or we can tell that by the periodic table because I only have 2 elements in that S sublevel region in that second row. So this represents that S sublevel, or that s orbital, and you only have 1 orbital in the s sublevel. So 2s, because we're in the second period on the second level, and you have 2 electrons there. Then over here in the p sublevel section, there's 1, 2, 3, 4, 5, 6 elements, meaning I need to have 6 electrons, and you can get 2 electrons in each orbital, so I need 3 orbitals. 3 times 2 is 6. So when I get to p over here, I need 1, 2, 3 inventory boxes. Okay, so here's 2, the second primary level, second period of the periodic table, second period on the periodic table, actually second energy level on the atom, second period on the periodic table, 2p, and we need to have electrons for all 6 of these elements. And when we get to the p sublevel, you can only put 1 electron in each of these orbitals before you can go back and pair them up. That's the Pauli exclusion principle, or it's governed by that anyway. So go back and read in an earlier lesson, or go back in the text and find the Pauli, P-A-U-L-I, exclusion principle, and make sure you're familiar with that. So we're going to put 1 electron in each of these boxes and then go back and pair them up. Okay? And so now we have this period is completely full, so we're at the point where we have the orbital notation for neon. So we're going to start the next period now, starting with sodium. So we're in that S sublevel region again. 2 elements, 2 electrons. This is the 3rd period on the periodic table, so we're in the 3rd level, electron energy level of the atom. So that's 3s, and we're going to have 2 electrons in 3s. Sodium and magnesium represent the position of those 2 electrons. Now we're over here where aluminum is. Again, we're getting into the p sublevel section. 1, 2, 3, 4, 5, 6 atoms, so 6 electrons and 3 orbitals. 2 electrons in each orbital. 3 times 2 is 6. So here we go. 1, 2, 3. So 3 orbitals here. I can get 1, 2, 3 more electrons, but I have to put them 1 in each box. Again, that goes to the Pauli exclusion principle that explains that. So this is 3p. We're in the p sublevel section. We're still in the 3rd period, the 3rd level of the periodic table here. So this is the 3rd level of an atom. This is the 3rd period of the periodic table. So we need 3 more electrons. 1, 2, 3, and that's the orbital notation for phosphorus. Okay? Now, for sulfur, then, I'm really just adding 1 more electron to this orbital notation. We're just building for each element, we're building up on the previous element. So here's sulfur's element symbol. You have to have the element symbol and a colon for the orbital notation. If you don't put that, I count off 2 points for that. Because element symbol and colon 1, 2, that's 2 points I count off when you do that on a test or homework or quiz. So make sure you have the element symbol and a colon. And everything that was there for phosphorus is also going to be there in sulfur. But we've got to have 1 more electron. Phosphorus has 15 protons. That's what that number right there at the top of this cell means, 15 protons. For an atom of phosphorus, not an ion of phosphorus, but for an atom of phosphorus, you have an equal number of electrons as protons. Protons are positively charged. Electrons are negatively charged. So the positive charges on the protons cancel out the negative charges on the electrons, and the atom has no charge, a neutral charge. Okay? So sulfur is going to have 16 electrons for the same reason. So I need 1 more electron, and after I put 1 electron in each of the orbitals in the p subsection, or p sublevel, then I can go and pair up, and that's sulfur. So chlorine just adds the next element here. Here's sulfur, here's chlorine. The chlorine just adds 1 more electron in there, following that same pattern. So here's chlorine. Okay, so I need 1 more electron now, And there's the next electron. We can put another electron in the p orbital, one of the empty orbitals. Okay, you always go from left to right. So when we get to argon, we're going to fill up that p sublevel. Okay, so here's argon, Ar. It's going to have all the same orbitals and electrons and sublevels that chlorine did, and for that matter, sulfur and phosphorus. We're just building on it. We need one more electron beyond what we have for chlorine, and there it is, and that's argon right there. Okay, so now we've gotten all of this third period full, and we're ready to go down to the fourth period, and there's potassium. Okay, so for potassium, we're going to have all this same stuff. Okay, all of this argon, orbital notation, electron configuration, it's all full. Or I'm sorry, orbital notation. We haven't talked about electron configurations. Actually, let me put, well, I'll keep doing it vertically. And so this is the orbital notation for argon, and potassium is going to have one more electron. That's going to be in the fourth concentric sphere, the fourth period. The fourth period is the periodic table here. That's the period here. So the fourth period will be another concentric sphere from the nucleus. 1, 2, 3, 4. That's where the electrons are actually going. And so we need to be in 4 here. And the first sublevel is always S. This is the S sublevel region, so potassium and calcium have electrons in the S sublevel. S, and you can only have one orbital in S, and an S sublevel only has one orbital and one electron for potassium. Calcium is going to have one more electron than that. So these arrows I'm putting in here, and they're kind of half arrows just because it's faster. These arrows represent spin. Electrons, we often symbolize those as an E negative, have a negative charge. That's what the negative is about. Like charges, things with the same charge tend to fly apart. If I have two particles or two balls that have the same charge, they're going to want to push apart from each other. So the way that we try to help explain the fact that these electrons can be in the same orbital is to give them opposite spins, which in theory cancels out that repulsion, that electromagnetic repulsion, the thing that pushes them apart. And so that's the same orbital notation for potassium. We need one more electron, and we're there. Okay? Now, that's orbital notation up to this point. When we get to this section in here, these are the transition metals. And this section, when we're talking about sublevel regions, this is the D sublevel region in here. Okay? So S is here in the first two columns with helium belonging right here. P are these 6 columns over here, and this is the D sublevel region. Somebody asked me in class yesterday, what is SP, and this now we're talking about D and F. What are they? What are those words? Well, there actually is a word, but it actually describes the lines you get when you do a spectroscopy, flame spectroscopy for these elements. And I know that's a little beyond this class right now, so let's don't spend too much time worrying about that. But if you want to talk about it outside of class, I'll be glad to tell you. I'll have to look it up. I don't even know what the name of the word is, what the word for the S or the word for P or D is, but that's what it is. It's a word that describes their what they look like when we're looking at a flame spectroscopy printout. Okay, so when we get into this transition metal section, this D sublevel section, we have to drop back a primary level. Now what I mean by that is these numbers here, 1, 2, and 3, and now we're in 4. We're going to drop back to the 3rd level when we fill up D. So we put electrons in 4 and 4s. Now when we get to D, we're going to drop back to 3D. Okay? And then when we finish 3D, we'll be back in 4, and this will be 4P over here. Let's see what that looks like. Let's start with scandium here. All right, so that's the orbital notation I have for calcium. And what we're going to do is get to 3D now. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements there. And since I can put 2 electrons in an orbital, and I need 10 electrons for these 10 elements, I need 5 orbitals or 5 boxes. But the Pauli exclusion principle still applies. So we're going to put 1 electron in each box, and when the whole set of boxes have 1 electron, then we can go back and pair up. So this is going to be 3D, not 4D. Okay? And for scandium, we need 1 electron here. All right? Then we just keep doing the same thing. We keep building up this stuff. So titanium. So the 3rd D sublevel, in the D sublevel section, we get D sublevels. We drop back 1 level, so that's 3D, 1 primary level from 4 to 3. Now, pause the video and you put in the electrons you need in 3D, and then restart the video and see where you are. Pause the video now. Okay, so we're going to have 1 electron that we had, the same one we have for scandium, and 1 more for titanium. Again, we've got to put 1 electron in each of these orbitals, and then after they're completely full, we can pair them up. Or, I'm sorry, after they all have 1 electron, meaning that's what I mean by that. You can pair them up. All right. So then, let's see. Let's go over here to. Let's go to iron. All right. We're going to skip over vanadium and chromium and manganese just while I'm here. don't confuse manganese with magnesium. Okay, the words are kind of the same. You'd think that's an Mg or that's an Mn. Don't confuse the symbols. Okay, be careful about the element symbols. You're not going to be required to memorize element symbols in this class or the periodic table. You don't have to do that, but you do need to be able to figure these things out from what's described about them. Okay, so we're going to go to, I said iron. And feel free to pause the video at any time and work ahead, okay? And then start the video and see if you understand, okay? So remember the rule, the Pauli exclusion principle rule. You can't put a second electron in any one of these orbitals until you first have one electron in each one. So I want to just stop right here, and I want to ask you to pause. You pause the video and complete the orbital notation for iron the best you can, and then start the video again and see if you got it right. Okay, that way you can practice. If you're not practicing, you're not really helping yourself get this stuff down so you can do it on a test. So pause the video now and finish and do that test. See if you can do the orbital notation based on the description for iron. Okay. So we've got 1s with 2 electrons, and 2s with 2 electrons, and I'm sorry, that should be 2p, and we put 1 in each box, and then pair them up. It's a little sad looking 2. I can get some white out and kind of clean that up a little bit if it bothers you. It kind of bothers me a little bit. That looks more like a 2. Alright, then 3s, then 3p, (4s). So iron needs 1, 2, 3, 4, 5, 6 electrons in this D sublevel. Okay? We're going to put 1 electron in each of these boxes. There are 5 boxes representing orbitals, or an inventory of sorts for orbitals.
Bus 34 is in bus waiting, bus number 34.
1, 2, 3, 4, 5, and the 6th one then gets paired up. Okay, so hopefully you did well with that. Then we'll just keep doing the same thing all the way through zinc. Let's do the orbital notation for zinc now. All right, help yourself out. If you're just copying down notes, it's not helping you. I want you to stop, pause the video, and try and fill this in for zinc, okay, using this pattern we talked about. And then restart the video. All right, so that's the orbital notation for zinc. Now, we've already filled up 3p, and we're in 3d. Don't make the mistake of thinking you're going to go back and put more electrons in 3p. That's full. We have to go back to the 4th primary level that we're in here. We started this row in 4. We're going to end up this row in 4. So after 3d is full, we're going to start putting electrons back into the 4th primary level, but in the D sublevel section over here.
Bus 12 is outside, bus number 12.
All right, we're going to be now in 4P. That's right here. And we're doing gallium at the moment. So there's 1, 2, 3, 4, 5, 6 elements in the P sublevel section in this row. That means we need 3 orbitals because we have 2 electrons in each orbital. So we want to put 1, 2, 3. Each P sublevel has 3 orbitals, even if they're not full. Okay? So all of this gets filled up, the same things we had filled up in zinc. Okay, everything up through 3D is full. These arrows, remember, represent electrons, and the up and down directions of those arrows indicate spin to keep them, allow them to be in the same orbital because they have the same charge. Okay, so we need one more electron then for gallium. That's going to go right here. So it follows that same pattern. Okay, so then we'll have the same pattern then in the P sublevel section that we had in these earlier levels, okay? Where we put 3 and then 4 and then 5 and 6 electrons in the P sublevel section to fill all these up. So let's do this. Let's assign for you, we call it classwork, homework classwork, okay? Because you might be doing it during this class, I don't know. But let's have you do arsenic, and I might come back and have you assign some more here in a minute. Arsenic and bromine and krypton. Okay, so we're going to do orbital notation for those. Okay, and then when we get down here to rubidium, now that's a whole new level, a whole new primary level. So remember, we had the nucleus here, and we had electrons in the first primary energy level, electrons in the second primary energy level. First and second, the first level is here. Second level includes both of these sublevels here. Then the 3rd primary level. That's 3s and 3p and 3d because 3 tells you the primary level. So s, p, and d electrons exist in 1, 2, in the 3rd primary energy level of the atom, and that's kind of tells you. You kind of figure out what's going on by where these elements are on the periodic table. Even though 3D is or the D sublevels are kind of weird here. So now we're about to start the 1, 2, 3, 4, 5th period. Okay. So you're going to do these assignments here through krypton, and we're going to start the 5th period now with rubidium. So we're going to have all these same orbitals. We're going to build on those things, okay? So the 5th period starts here, and we're going to have electrons again. These first two columns are the s sublevel region, so this will be the 5th level, 5s. Okay, 1, 2, 3, 4, and now we're in the 5th primary energy level. And 5s just has one orbital.
Bus 43 will be in bus loading, bus number 43.
And so rubidium just has one electron here, and that's done. Okay? So let's add to this list to do strontium for classwork and homework. Okay? And then when you get, so this is 5s, when we get to the D sublevel region in here, you're going to drop back a level. So when we went to the D sublevel region here, we dropped back from 4s to 3D. Now we're going to drop back from 5s to 4D. So after we get the strontium orbital notation, we'll go to 4D. So let's do yttrium together. It would be a really good idea, I'm not going to make you do or ask you strongly to do this, but it would be a really good idea if you were to pause the video and do this one for yourself first, and then play the video again and see how you did. See if you can figure it out for yourself. I started to put too many boxes there. Thought it didn't look quite right. All right, so we're now at 5s, 5 rows, 1, 2, 3, 4, 5. 5s is this section right here, and we're going to yttrium. So this is going to be one level down from 5, 4D. This is the D sublevel section in here, 4D. And we need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We need room for 10 electrons, and each orbital can have 2, so we need 5 orbitals in 4D. Okay, so every time we come to a D sublevel, it's always going to have 5 orbitals. Every time we come to a P sublevel, it's always going to have 3 orbitals. Every time we come to an S sublevel, it's going to have 1 orbital. For yttrium, we need 1 more electron. Okay? All right, then, let's pick another element somewhere in here to have you do as classwork homework. Let's have you do ruthenium. Okay? And then I'm going to go over here to get just outside the 4D sublevel and do, well, let's go to 10. Let's do 10 first, okay? Again, it would be a really good idea if you were to pause the video and finish this up for yourself and then play the video and check your work and see if your work matches what I have, okay? So I would recommend you do that because I want you to do well. I want you to practice as much as you will. So all these letters should be lowercase letters. So that 5 and that S look like the same size. I really need to make the 5 a capital 5, or a larger 5 rather, the size of a capital letter, and make the S a lowercase letter. So I'm going to kind of work it out here. I'm going to work it out like this, and pencil in 5. Okay. All right. So 2 electrons in an S orbital, 6 electrons in a P sublevel, 2 electrons, 6, 1 in each orbital. Come back and pair them up. 2 electrons in S. Then we got 10 electrons in D, 1 in each orbital, and then come back and pair them up. P has 3 orbitals, 6 electrons, 1 electron in each orbital, and then pair them up. S orbitals have only 2 electrons. S sublevels only have 1 orbital. And we're talking about 10, so we have this D sublevel completely full. 1 in each orbital. Come back and pair them up for a total of 10 electrons. And now we're going to go to 5D. And you got to have 3 orbitals in a D sublevel, even if they're empty, or really once you have 1 electron there, you have to have 3 orbitals. The boxes can be partially empty, but if you have even 1 electron in this D sublevel, you got to have all 3 boxes there. So we need 2 more electrons for 10. We've got all of this filled up. We need 2 more electrons in this D sublevel section. And so we're going to put 1 in each box, and we're not ready to pair them up until we have 1 in each of all of those boxes, okay? All right, so that's 10. So let's have you do iodine. And then I'm going to also have you come down here on the next row and do barium, okay? Now, this is as far, actually lanthanum is as far as we will go in doing orbital notations. You are going to, we're going to talk about the F sublevel. Well, this down here is the F sublevel region, and there's 14 atoms in each of these rows, okay? And so that means we need 7 orbitals. So in the S sublevel, you have 1 orbital. In the P sublevel, you have 3 orbitals. In the D sublevel, you have 5 orbitals. And the F sublevel, you have 7 orbitals. So it goes up in odd numbers, okay? S, 1, P, 3, D, 5, F, 7, okay? And so I will talk to you in the next class about how we can put in or skip over that F sublevel region here when we do the orbital notations for these things. When we do your element cubes, there won't be enough room to put an orbital notation this big. And so for those, what we're going to do is we're going to kind of do a shorthand version of orbital notation. Let's take a look here. Here, this is 10. And if we were looking at the next lowest noble gas, here's 10. And if we count backwards from 10, 50, 49, 48, and so forth, until we get to a noble gas, the next lowest noble gas is krypton. All the elements in this column are noble gases. So if you want to work on your element cube to create your orbital notation for your element cube, this is how we're going to do that. If we were writing this is only allowed on the element cube, not in any other context are you allowed to do orbital notations in this way. But just to fit orbital notations into our element cube, we're going to do it like this. So this is a special case, 10. Now krypton has the orbital notation that goes through 4p. And rather than write all of this between my finger and thumb, well, it's just between the two thumbs here, between the two thumbs, this is the orbital notation for krypton. We're going to skip all that over and just put in its place krypton, its symbol, in a bracket. Okay? Got that? We're even going to skip the 4D section. So we're going to write this out. This is how you're going to put it in your element cube for these, okay? So we only need the highest energy level. In this case, the highest energy level is 5s and d. The fifth level is the highest primary energy level. S electrons and d electrons will always be in the highest level. So we're going to put 5s like this. And we're going to skip 4D. I need to show that it's there by just putting a dash here, or slash, a forward slash. So a forward slash leans in this direction. A backslash leans in this direction. We're going to use a forward slash. And remember, this only is allowed if we're doing your element cube. And then we need 5D. Only allowed on the element cube. That's the orbital notation you're allowed to do for any elements past, let's say, past neon. So up through neon, you've got to do the full orbital notation. After neon, you can do a kind of shorthand orbital notation. That's not allowed on tests. It's not allowed on quizzes. Not allowed on homework or classwork. Only on the element cube. So if that helps you as you work on your element cube project, that's how you can do that. And then in the next in-class lesson, we'll start talking about electron configurations. Once you understand orbital notation, electron configurations become easy. It really does. And it's simpler to write, but doesn't give you as much detail. So do this classwork homework up here, the orbital notation for these problems here, and then you're going to turn that in on Google Classroom for a grade. We'll I'll tell you what, you could just do those on a separate sheet of paper. Make sure your name is in the upper right hand corner. On paperwork, when you turn in papers, that's just something written on paper. You need to put your name in the top, last name, first name. That's what we always do, last name, comma, first name. Okay. And then you want the date, and the date format is always 4-digit year. Okay. 2-digit month. So if the month is September, that's 09. If the month is August, that's 08. If the month is December, that's 12. So a 2-digit month and a 2-digit date. So if the date is the 2nd, you can't just write 2, you must write 02. Okay? So that's the date format. So this date, at the time I'm doing this anyway, is 2020, 2020-08, I'm sorry, this is 09-03, okay? So that's just an example of the date format. So you have to do your dates in that format. All right? And then you have to have a description of what the work is. If it's homework, you can just write HW. Okay? Any other kind of work, you might have to give me a more complete description of it. Well, this is actually homework, classwork. Okay? And then the last line here, you need to tell me who the teacher is. That's always going to be me. And you can write Tedder. That's good enough. You can write Mr. T if you want to. Sometimes students have wanted to call me Mr. T in the past, and I've been fine with that. But Mr. Tedder, or Mr. T, let's stick with one of those three, okay? So that's how you write out your on the top right corner of all your work. Now, since these orbital notations are kind of long, you might want to turn your paper this way to do it and put this information in the upper right hand corner over here. Now then you're going to scan that and upload it to Google Drive, and you're going to then submit. You can upload it as a PDF and submit the PDF for a homework classwork grade.